Thus far, the top bound of our summation has always been a nice expression, like n, or we wrote it as a number. It does not need to be a number. It can be any integer. So here, we have a summation that is a function of n, but that top bound is some polynomial in n. This will turn out to show up lots of the time when we are analyzing our code. So we need to be able to deal with this. Notice, it's just an integer though. Our formulas will still hold because they were true for any integer or any natural number depending upon the particular formula. So, the fact that that is 3n squared plus 2n plus 1 does not really matter. That is still an integer. The integers are closed under multiplication, squaring, and addition, so it is an integer. So we need to do something similar to try to exploit one of our formulas. Notice first that this is a geometric looking sum. We have a number raised to the I, so we're going to try to use our finite geometric sum formula. This is equal to, you can factor constants out using linearity like we did in the previous problem. I goes from 0 to that top bound of 3n squared plus 2n plus 1 of 4 to the I. We can then use another known formula as we did in the past. We have this formula for a geometric sum, which says if it goes from 0 to n of r to the I, this is equal to 1 minus r to the n plus 1 divided by 1 minus r. And in our case, r is going to be 4, and n is going to be 3n squared plus 2n plus 1. And now we just need to plug in those values into the formula. This is equal to 3 times, use those values in the formula, and we have 1 minus r. R is equal to 4, though, to the n plus 1, but n here is 3n squared plus 2n plus 1 divided by 1 minus r. This is equal to, the denominator there is negative 3. That cancels with the 3 and gives me a negative 1 times 1 minus 4 to the 3n squared plus 2n plus 2. You could then try to further simplify by distributing the negative 1. However, it's not particularly important to us. We just wanted a closed form expression. Notice, again, it did not matter that the top bound was this horrible mess of a polynomial. This formula still works just fine.